In the previous video, we have seen Professor Albert explaining the importance of PCA to our granny. PCA identifies the best combination of attributes that explain the given dataset. In this video, we're going to see how does PCA discover the new attributes. Granny says, tell me more. PCA is interesting. You said PCA finds attributes that best summarize the data. What do you mean by best possible summary? To which Albert says, let me explain with a simple example. Look at the below data and imagine that your daughter's promotion at work is dependent on 4 attributes. 4 things: gender, work experience, salary, age. And here you see some of the other colleagues at her workplace getting promoted and not getting promoted based on a combination of these attributes. Now, you tell me which attributes are useful in predicting whether your daughter is going to get promoted or not. Out of these 4 attributes, which attributes do you think are important? Just look at the data. Granny is intelligent. So Granny looks at the data and says, gender can be ignored as all of them are females. If everybody is a female, how can that attribute play an importance in deciding whether my little girl gets promoted or not? Albert says, correct, but look closely. Is gender the only attribute that is not useful? Work experience, salary, age. Granny says, just like how you guys are thinking, Granny also thought about the exact same thing, and Granny says, I see. Age also seems to be unimportant as all of them seem to be between 25 to 26 years. Both of them you can just ignore because they're practically saying that all of them are the same, which is not the case, isn't it? Had all of them been the same, then everybody should be either getting promoted or not getting promoted. But you know that some of them got promoted, some of them did not get promoted. So there must be something that explains this variance. Albert says, correct. PCA also behaves exactly the way you just behaved. PCA tries to identify attributes like work experience and salary that are most important in understanding the given dataset. They're important because they have more variance. Compared to columns like gender and age, you can just ignore because they are the same across all the data points. They're the same for all the colleagues. This is exactly how the data looks like for all of them. You see that work experience and salary, there is a lot of variance. Work experience ranges from 3 to 15, whereas salary ranges from 20 to 65. Got it. That's what Granny says. It's simple. Can you explain summarizing? Pizza example, I understood summarizing from this example, talking about my daughter's promotion. But can you explain that with our pizza example? How does summarization come into picture and how is PCA coming up with these new attributes? Albert says, coming back to our pizza example, there are 2 ways to understand how PCA does summarization. First answer is that you are looking for some pizza properties similar to work experience and salary that strongly differ across pizzas. Granny says, like, what kind of attributes? Albert says, say if all the pizzas we are considering are of 7-inch crust size and are of the same price. Now if PCA comes up with an attribute that just sums up crust size and price, will it be useful? Granny says, nope. This new attribute will be like the gender attribute or the age attribute that we saw in the previous example, and all the pizzas look exactly the same. If PCA comes up with these attributes, I'm going to beat PCA. Albert says, exactly. The new attribute would not make sense and would badly summarize our pizzas. Instead, PCA looks for properties that show as much variation across pizzas as possible. It comes up with these linear combinations that exhibit as much variation across all the data points as possible. That is just nice. So basically, PCA tries to come up with attributes like work experience and salary in the pizza's dataset. Now, Granny says, what is the second answer? This is the first answer. What is the second answer? Albert says the second answer is that you also look for properties that would allow you to predict or reconstruct the original pizza attributes. So whatever new attributes that PCA is coming up with, if you take these three principal components, you are seeing 2 times taste plus 3 times size minus 1.5 times price. Even if you don't find these kind of attributes in real world, you're coming up with a linear combination of real world attributes like taste, size and price. PCA always ensures that these old attributes, the original attributes, can be reconstructed from these new attributes. Granny says, sounds plausible, but what do you mean by that? Albert says, imagine that PCA came up with a property that has no relation with the original attributes, like the time it takes to eat a pizza. That attribute we have not considered. These were the original attributes, right? So the time was never part of the original attributes. Imagine PCA came up with that new attribute. Will that be useful? Because there is no way you can reconstruct any of the original attributes that you see here. Do you see time anywhere? No. Granny also recognizes that and says, true, if PCA comes up with an attribute that is totally different and has no relation with the old attributes, original attributes, then that would be a really bad summary. Albert says, exactly. That's the reason why PCA looks for properties, attributes that allow to reconstruct the original characteristics as well as possible. And surprisingly, magically, if you ask me, it turns out that these two aims are equivalent, and so PCA can kill 2 birds with 1 stone. PCA, whenever it comes up with these new attributes explain the maximum variance in the dataset, and at the same time, they can also be used to reconstruct the original attributes with minimal reconstruction error. Sounds surprising, isn't it? That's exactly what Granny says. Interesting. PCA is indeed some concept. So how does PCA find the new attributes? We have learned that it selects the linear combination of attributes that explain the maximum variance in the dataset, and at the same time, it selects the linear combination of attributes that can be used to reconstruct the original attributes with minimal error. Surprisingly, both these are true at the same time. How is that possible? That's what we're going to see in the next recording, where we're going to visually explain PCA using scatter plots. Until then, this is Machine Learning Granny signing off.